In the previous video, I showed you how to find the area and perimeter of a polygon. In this video, we're going to do the area and perimeter of a circle, but for a circle, it's not called perimeter, it's called the circumference. Also, I'm going to show you how to find the length of a portion of a circle that's called an arc. So if that's a circle, then this portion of the circle would be called an arc. It's disappearing on me, but you get the idea. That's an arc. Now, if I make a little slice out of this, almost like a slice of pizza, then this slice is called a sector. So I will also show you how to find the area of a sector. So for number 7 says a circle has radius 9 feet. Then the area of the sector that has a central angle of 80. Central angle of 80 means like this would be 80 right here. Anyway, that's in my way. All right, but we're supposed to find the area of the sector. So here's the formula for the area of a sector. The area of a sector is going to be always some fraction of the area of the whole circle. Okay, now the area of the whole circle is pi r squared. So that makes this the formula for the area of a sector. It's some fraction of the total area of the circle. Now that theta in the numerator is the central angle, or you could call it the measure of the arc. Anyway, so I can just substitute 80 in for theta, and I can substitute 9 in for r. So, since everything I need is on the right-hand side of the equation, I really can just put this entire thing in my calculator just like that. Okay, so if I do, that's going to look like this. 80 over 360 times pi 9 squared. I can just put the whole thing in. And that gives me 18 pi. So that's why the answer is going to be C, 18 pi square feet. On a certain circle, 120-degree arc is 44 centimeters long. Okay, which of these is the best approximation of the circle's radius? Okay, so they are giving us the arc length. All right, the arc length. So that tells me that we're going to need to write the formula for arc length. All right, now remember, arc length is a portion of a circle. So if that's a circle, then this portion of the circle would be an arc. And imagine that that was 44 centimeters long, like from here to here. Well, that is some fraction of the circle. So the formula for the length of an arc is always some fraction of the whole circle. Now the length of the entire circle, that's called the circumference, and that is 2 pi r. So that makes this the formula for arc length. So in this case, they're asking us to find the radius. That's what we're looking for. So that means we are given the arc length and we are given theta, all right, which is either the central angle or the arc measure. It's going to be degrees. Theta is degrees, so look out for degrees. So we're given the arc length, which is 44 centimeters long. So the 44 goes first. We are given 120 degrees. That is theta. So that's 120 degrees out of 360, okay, times 2 pi r. Now I like to reduce this, all right, when I have to solve the equation. If I can't just put it all in my calculator in one step, then I like to reduce this. So if I reduce this, I've got 120 over 360. Okay, that's 1/3. So that means I have 44 is equal to 1/3 times 2 pi r. So the best way to fix this is multiply by 3 on both sides to get rid of the fractional aspect of it. That way these 3's will cancel each other out. Okay, so that leaves me with, well, 3 times 44. Let's check into that first. That's 132. So that leaves me with 132 is equal to 2 pi r. I'm trying to get r by itself. Okay, so I'm going to divide both sides by 2 pi. All right, that way the 2's and the pi's will cancel each other out, and this should give me the radius. So what is this going to be? So I need to do 132 over 2 pi. So that's 21.01. Okay, so the best approximation is 21. 21.01 is very close to 21. Okay, well, actually, they want me to put B. This is multiple choice, so I'm just going to put B right here. All right, for problem number 9, this circle has a radius of 12. Then the measure of the bold arc is 138 degrees, which is right there, same as the central angle. Find the length of the bold arc. So this is arc length. So let's use the arc length formula. The length is always going to be some fraction of the whole length. All right, the whole circumference, which is 2 pi r. So this is the formula for arc length. Now, we know theta, okay, because that's 138, and we know r, because that's 12 feet. So I'm just going to substitute both of those things in. So the arc length is going to be 138 over 360 times 2 pi 12. And so really I could just put all of this in my calculator just like it is. All right, because that just leaves L by itself. So if I put that in my calculator, I'm going to have 138 over 360, all right, times 2 pi 12. Okay, so that's the exact answer. Maybe I'll write that down, 46 pi over 5. Okay, but they want decimals, so I'm going to go ahead and toggle it. That's 28.90. All right, this circle has a radius of 15, and the length of the bold arc is 8 pi centimeters. Find the measure of the central angle. So we're being asked to find theta. That's what we're looking for. We are given L, because that's the arc length, and we're given R. Anyway, we're dealing with arc length, so let's once again use the arc length formula. The arc length is always going to be some fraction of the entire circumference, which is 2 pi r. And we're being asked to find the measure of the central angle. So we're looking for theta. So let's substitute in what we have. L is 8 pi, so we'll have 8 pi right there. And then we'll just have to leave theta, because that's what we're looking for. Okay, and then it's going to be times 2 pi r. So that'll be 2 pi 15. Okay. So I need to get rid of this fraction business. So that's why I'm going to go ahead and multiply both sides by 360. All right, that way these will cancel each other out. So when I recopy this, I will have 360 times 8. So that's 2,880 pi. And that leaves theta times, so 2 pi times 15, that's 30 pi. Let's go ahead and just put 30 pi down. So remember, we're trying to get theta by itself. So that means we need to divide both sides by 30 pi. That will get theta alone. Alright, so the 30 pi cancels out. Theta is now by itself. Over here on the left, the pi's cancel out, so I don't need to bother even putting that in my calculator. So really I'm just going to do 2,880 divided by 30. So that's 96. So that means theta is 96 degrees. Number 11, the shaded sector has a central angle of 150 degrees. Well, there's theta right there, as soon as I see 150 degrees, and an area of 650 square yards. So that's A, the area of the sector. Find the circle's radius. Alright, so that's R is what we're looking for. Okay, and that's marked X. Show your work. So we're dealing with the area of a sector. So let's start by writing down the whole formula. The area of a sector is always some fraction of the whole area. The area of the whole circle is pi r squared. So some fraction of pi r squared. Now we're looking for r. That means we must be given A and theta. So A is 650, like we said. So that goes here. Theta is 150. So I have 150 over 360 times pi r squared. Now, the following step is not mandatory, but I think it's a good idea to reduce this fraction, just to help keep the numbers smaller. So 150 over 360, that's 5/12. So that means I have 650 is equal to 5/12 times pi r squared. To eliminate the fraction, all you have to do is multiply by 12 on both sides. That will cancel out the denominator of 12. So the 12s cancel each other out, and now we need to see what 12 times 650 is. So that's 7,800. And that's equal to 5 pi r squared. Now remember, we're trying to get r by itself. So our next move is to divide both sides by 5 pi. Alright, so the 5 pi cancels out that 5 pi. So that leaves us with 7,800 over 5 pi is equal to r squared. Now we need to unsquare this, so we need to take the square root of both sides. Do not turn this into a decimal ahead of time. That's too much rounding. Let's just take the square root of both sides now. So this will be the final answer. So we will do the square root of 7,800 over 5 pi. So that is 22.28. So that's number 11. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.